energy efficiency and also in energy certification. And today we're going to talk about this, about energy certification in buildings, specifically in the residential sector. Well, after talking about certification context as an introduction, as a brief introduction, we're going to focus in the regulatory framework. Then I'm going to explain what's an energy certification. We're going to see how we simulate a building and why we do it, what information we need and what we obtain, and what's the purpose and the main advantages of certification, of building certification. We're going to differentiate mandatory and voluntary certifications, and finally, we're going to focus in the conclusions and saving opportunities of residential energy certification. When talking about building certification for residential, it's important to differentiate between mandatory, like all the certification created from European Union Directive 2010-31, and all the voluntary building certifications, the one we obtain to demonstrate our environmental commitment but are not mandatory. It's also necessary to divide the certifications in other two groups, the pure energy certifications, as the one we obtain with an official software like Calener or Energy Plus, and the certification that consider energy efficiency, but also other environmental aspects, such as water use, recycling, etc. In this group, we can find the LEED certification or the BREEAM certification that are not only energy efficiency, but environmental certifications. Well, the starting point, the first thing we need to know is that a residential building is a small energy consumer. If we compare this building with a shopping center, a hospital, or a hotel, the energy consumption in kilowatts-hour per square meter is significantly lower. This low consumption is caused because we usually don't have big machines, big equipment at home, and also the use of the homes, the yearly hours of use, are much lower than in other facilities. But as we can see in this graph, there are a lot of residential buildings. In Europe, 75% of buildings are residential buildings. So we find here a large and dispersed sector, many facilities, but a small consumption per facility. This usually means low efficiency, and usually means that it's complicated to act, and usually measures are less profitable, being the use lower. So what we find here in the starting point is a dispersed sector with a high potential for energy efficiency. That's why it's important to take actions, such as the energy certification. Another interesting data, 40% of European buildings were built before 1960. The three graphs we can see at the bottom of the slide, we can see the distribution of buildings depending on when they were built. In South Europe, North and West Europe, and Central and East Europe. And we can see that in all three regions, the buildings built before 1960 are between 35% and 45%. The new buildings, the ones that were built after 1990, and theoretically the most efficient, represent less than 20% of residential buildings in all regions. All said, we can confirm that an energy renovation is needed. Okay. Here we can see the energy fields in the residential sector, also in the three regions in Europe. We can see that 32% of residential buildings in South Europe uses oil as a fuel, and 40% of residential buildings in Central and East Europe uses coal as a fuel. Renewable sources, basically biomass, represent 27%, 20%, and 20%, depending on the region. And finally, we can see that in Central and East Europe, there is a significant percentage of energy consumption covered with district heating. This is interesting because there is the possibility of energy improvement actions in district heating. Well, let's focus now in the regulatory framework, mainly in Europe, because the countries of Europe, the European Union is the most advanced group of countries in energy efficiency when we're talking about energy efficiency. We find three different directives And remember, in Europe, a directive is the equivalent of European law. There are no European laws, there are directives. And the European states must create a specific law to comply with the requirements of the European directives. So we find here three directives. The first one, the 93/76. The European member states should take actions to reduce buildings' energy consumption. And the energy certification is defined like a tool used to classify buildings regarding their energy consumption. The next directive, the 2006-31, set already indicative targets, and it promotes efficiency in the use of final energy. And it sets conditions for energy service market development. And finally, the most important, the latest, the Directive 2010-31, the EPDD, all member states should take measures to ensure that from 2020, all new buildings are nearly zero energy consumption. And in case of public buildings, 2018. The most important points of the directive, of the EPBD, are it gives us a method for calculating the energy efficiency in new construction buildings. It promotes energy efficiency in EU buildings, taking into account outdoor climatic conditions and profitability in terms of cost effectiveness. And the member states shall ensure that the energy certification is issued for buildings sold or rented, new construction buildings, and public authority buildings. The EPBD has been implemented in 29 countries, the UE 27, Norway, and Croatia. Let me draw your attention to this graph here in the right of the slide. This graph shows the evolution of number of countries with schemes for buildings, for energy efficiency in buildings. We can see that most countries start taking measures after 2005, and right now there are almost 30 countries with running schemes for energy efficiency in buildings. The average energy consumption in the residential sector in Europe is 168 kilowatts hour per square meter. It's growing. Right now it's growing due to the high number of domestic electronic appliances. But the thermal demand, the heat and consumption, the average is decreasing in all countries. You can see these three graphs. In these three graphs, we see the average energy consumption, the evolution of the average energy consumption for heating in three countries, Germany, Portugal, and Bulgaria. We can see that in the last 30 years, the heating consumption has been reduced in all three countries. Also, we can see that in Germany is a cold country which is really committed with energy efficiency. The heating consumption is not much higher than Portugal. Right now we're talking of 68, it's lower than Portugal and also lower than Bulgaria. So energy efficiency actions really have an impact in the energy consumption of the buildings. Outside Europe, there are no much regulations. We have some regulation in USA, although there is no mandatory energy labeling pathway, but there are regulations on minimum energy efficiency with which buildings must meet. We find the Hertz index. The Hertz index is a measurement of a home's energy efficiency. The Hertz index is voluntary, it's not mandatory, but some states, such as California, have made Hertz certification mandatory. We also find some regulation in China and Australia with a system called the Energy Stars, and they use for labeling these Energy Stars. In Australia, it's for homes and in all buildings in China. But the main regulations is in Europe. Okay. So let's see what's an energy certification. The energy certificate is the document that a qualified technician delivers to the building owner with the grade that the building has obtained considering the weather conditions, the construction characteristics, and the energy consumption. As shown in this graph at the right of the slide, we are getting usually a letter with the building grade. As in lamps or home appliances, an A means less energy consumption, more efficiency, a better grade. As an example, in Spain, it's really difficult to obtain an A or a B in the building. For that, it's usually necessary to have some renewable energies like photovoltaic or biomass. We get this energy grade with an energy simulation. The energy simulations, we have to simulate the building. The first thing to consider are the weather conditions. We have to know, we need to know the location of the building, the climatic zone according to regulations. Then we define the thermal envelope, the area, orientation, the constructive solution of facades, the thermal transmittance, and this is for the windows, for the walls, for the roof, etc. And after the thermal envelope of the building, we define the systems. Usually, the heat generating system, the cool generating system, and even the hot water generating system. And so in some softwares, we can define also the lighting system, but that's not that usual. Once we've made this simulation, the software calculates the energy consumption of the building and provides the grade based on its energy consumption compared with the reference. The energy certification takes the form of a label. We can see the label here. Okay? It is issued by the competent authority, which validates the energy rating developed by a qualified technician. We have the scale. We can see here the scale. In this case, it's from A, the most efficient, to G, the least efficient. Also, the primary energy consumption in kilowatts hour per year and per square meter, and the CO2 emissions. Okay? As I just said, the grade is based on emissions, CO2 emissions per square meter per year, primary energy consumption in kilowatts hour per square meter per year, and the demand for heating and cooling in kilowatts hour per square meter per year. And finally, the certification, many softwares gives us some possibilities for improvement. For example, improving the thermal envelope, improving the systems, or even renewable energies. Let's see an example. This is an actual building in Madrid, in Spain. It's a residential building in Madrid where the weather is cold in winter and really hot in summer. So usually we need heating and cooling systems. We can see here some characteristics of the building, the area, the number of apartments, and the envelope transmittance. The transmittance of a window or of a wall is the capacity for heat transmission. The higher the transmittance, the worse is the envelope in terms of protecting the indoor temperature. What we can see here is that the transmittance of the window is much higher than the transmittance of the facades. Okay, this means that the heat escapes over the windows. Of course, we have to consider also the surface. The window transmittance is higher, but the window surface is much lower. So we have to take into account both things. The transmittance is especially interesting for comparing different elements. And we see here also the building systems. When simulating the building, we consider also the heating and the cooling systems, not only the envelope, because we're going to grade the building based on its energy consumption, not only the energy demand. So the systems are important. Here we have gas boilers, 5 gas boilers, 5 heat pumps, and some electric heaters for the hot water. So considering all this, we simulate the building with a 3D model in which we draw the building. Okay, we must draw the building using proper software, and then we add all the transmittance and thermal data for the envelope and describe the different systems. Finally, we obtain the results, the current qualification, the current grade. Here we can see the results of the simulation. The energy grade, here, let me show you, we have our building has an F, so it's not a very good building. And it's compared with our reference building, which is a little better, has an E. Okay, this software is the one we use in Spain. It's called Calendar. compares the building we have simulated, which is the first one, with a reference building. And based on this comparison, it grades our building. What we're going to see now in the next slides is how the grade improves when we apply improvement measures. First, we are simulating the same building but placing awnings on the south side. We can see there is a reduction of cooling demand in 406.5 kilowatts hour a year, and also a reduction of cooling emissions. But if you see the letters, the grade is the same, an F. Okay, the grade is not improved. We're going to see another action. The second one, double glazing for the windows. Installing double glazing to improve the thermal transmittance to 2.78 watts per square meter per Kelvin. We have a reduction of heating demand in 10.8 kilowatts hour per square meter. And here, the grade is improved. Now we have an E. Finally, we simulate the same building considering more insulation. When I say insulation, I refer thermal insulation in walls and in the roof. The results are a reduction of heating demand in 73.4 kilowatts hour per square meter, and also a reduction of cooling demand in 1.9 kilowatts hour per square meter. Here, the grade is also improved. We have an E. This final slide shows the simulation with 4 actions combined. We have added insulation in walls and roof, the double glazing for the windows, placing awning on south side, and installation of 3 condensing boilers. Here, the letter improves even more. We have a D. Our new grade would be a D. So with an energy certification, we obtain 2 main results. First, information about our energy consumption, and information about some efficiency improvement actions. Let's talk about simulation software. There are a lot of simulation software. We are talking about the 2 more common. The first would be Energy Plus. The Energy Plus, it's an energy analysis and thermal load simulation program. It was created by the US Department of Energy. This program, this software, calculates heating and cooling loads necessary to maintain thermal control set points. It's a standalone simulation program without a user-friendly graphical interface, but there are a number of graphical interfaces available. But it's important to acknowledge that this is a simulation software. We can simulate the building, but this is not a certification software. Okay, this software is not going to grade our building. Most European countries have their official software for certification. There is another known software for simulation called eQuest. As Energy Plus, eQuest only simulates the building, doesn't grade it. This is a freeware tool and an easy-to-use building energy analysis tool. This is accomplished by combining a building creation wizard, an energy efficiency measure wizard, and a graphical results display module with an enhanced DOE to derive. Well, after this, we're going to talk about mandatory energy certification in Europe. We're going to see the basic laws in different countries. First, Germany. There is an energy certification called Energy Pass from 2002, and also an energy saving ordinance, also in 2002. It sets a maximum power consumption for the buildings in 120 kilowatts hour per square meter. It sets the thermal transmittance limit values for elements of the envelope and the requirements of efficiency in the heating system. We compare the estimated annual demand of primary energy of the building with a reference baseline established depending on the shape coefficient. We did that too in the example we've seen before. In England, there is an energy certification from 1995, but it's mandatory since 2007. The classification in this country is called SAP. It stands for a Standard Assessment Procedure, and it goes from, this is not letters, this is numbers, goes from 1, which corresponds to the lower energy quality, to 100. It consists of a static balance of energy demand, which delivers as a result of CO2 emissions per year. For the demand of energy is considered heating, hot water, and energy used for pumps and fans. A rating is given regarding its energy behavior and its impact on the environment. Let's see another country. In Denmark, there are mandatory certification schemes existing from 1997. The implementation of the directive, of the European Directive EPBD, with respect to certification is the responsibility of the DEA, the Danish Energy Agency. There are 2 available tools for energy certification, and the Energy Performance Certificate assigns an energy performance label, classifies the building, like we said before in Spain, in a scale ranging from A to G, and also gives some recommendations. Recommendations are given to the building owner, including a short description, estimation of cost, savings, and paybacks. In Ireland, there are certification schemes existing since 1997. There is a calculation methodology for new residential buildings. It's called the Dwelling Energy Assessment Procedure, DEAP. The DEAP generates a building energy rating for new and existing dwellings and demonstrates compliance with the specific aspects of energy regulation for new buildings. You can see that all the regulations are similar, and all countries have a software that calculates annual values of delivered energy consumption, like we are seeing here in Ireland. It calculates also primary energy consumption, CO2 emission, and cost, both totals and per square meter. In Portugal, there are mandatory certification schemes existing since 1997, and the European EPBD was transposed into the Portuguese legislation in 2006. Energy calculations can be done to show compliance with building regulation requirements. A software tool is used also in Portugal, developed by the National Institute of Engineering, Technology and Innovation. This software gives the following information: building energy rating, CO2 emissions for the building, indoor air quality, and upgrade recommendations. In Spain, there is a law, 235 from 2013, brings together the requirements of energy certification of new buildings and also includes the obligation for existing buildings. In particular, any building that is likely to be sold or leased. Also includes the buildings in which the public authority occupies a total useful area over 250 square meters. There are software, we talked before about the calendar, a special software, and also a software called CE3X. There are different tools. Well, these have been some examples of countries with mandatory energy certification, all in Europe, but we're talking a little further about voluntary energy certification. There is not only mandatory certification, we find many buildings certified with voluntary programs. We're going to see the most common. The most common would be the LEED program, created by the US Green Building Council. The BREEAM is a British program. The DGNB system is a German program. Also in German, there's the next one, the Passive House. The HQE is a French program. And finally, the Minergie is a Swiss program. The most common, the market leader is the BREEAM, is the market leader, the world leader, and also the European leader, accounting for more than 80% of all sustainable commercial building certifications in Europe. And in total, the four major schemes, BREEAM, LEED, DGNB, and HQE, reported almost 10,000 certifications between 2012 and the 3 first months of 2013. Well, let's study with further detail these programs, or some of these programs. The LEED certification is the American one. LEED stands for Leadership in Energy and Environmental Design. It's a voluntary system of evaluation and certification of building sustainability. It was designed by the US Green Building Council, and remember that LEED grades the building not based only in energy consumption, but is an environmental grade. But energy consumption plays an important role in the grade. As we can see here, LEED evaluates the sustainability of buildings, resulting in 7 main areas: sustainable site, water use efficiency, energy efficiency, materials and natural resources, indoor environmental quality, design innovation, and regional priority. There are 4 categories. The first one is just LEED certified. It depends on the points we get in the simulation, from 40 to 49 points. And we have the silver, the LEED silver to 59 points, the LEED gold to 79 points, and the LEED platinum. Here we can see a picture of the Hearst Tower in New York City. This tower was designed by Norman Foster, and it gets a LEED gold. It got a LEED gold. It's the most environmentally friendly office tower in New York City. The BREEAM program, BREEAM stands for Building Research Establishment Environmental Assessment Methodology. It's a certification, a voluntary certification system of evaluation and certification of sustainability. BREEAM evaluates the 3 pillars of sustainability. These pillars are society, economy, and environment, through impact assessment resulting in 10 main categories. These categories are management, energy, water, health and wellness, transport, materials, ecological land use, waste, innovation, and contamination. So, as LEED is not only based in energy consumption, but as we can see here, the energy consumption plays an important role. Here we can find some benefits from the BREEAM certification. Well, we can see it's known internationally, it's the world leader in environmental evaluation system building. We can get a global vision of sustainability. As we saw, it analyzes a large number of environmental aspects. We can get a reduction of maintenance and operation cost in the building. We can increase the user satisfaction by improving the building's internal environment. And we get an improved functionality, flexibility, and durability of the buildings. Another program, we have here a German program called Standard Passive House. This is an energy certification because it values only the energy. And it has 7 basic principles. The support insulation, the heating and the cooling demand must be lower than 15 kilowatts hour per square meter. Elimination of thermal breaches, the seepage control, mechanical ventilation with heat recovery, windows and doors with high performance, and optimization of solar and internal heat gains. The energy modeling, the total primary energy must be lower than 120 kilowatts hour per square meter. Let's see an example. There's a house in Spain. You can see in this table that the heating demand is only 13 kilowatts hour per square meter per year. The cooling demand, it's only 3 kilowatts hour per square meter per year. And for example, let's see the last row, when we can see the glass transmittance, it's only 1.1 watts per square meter per Kelvin. Compared with the last example we saw, the building in Madrid, in which the transmittance of the windows was 5.7. Well, finally, let's see some conclusions of this. The question would be, what goal have the energy certification of the buildings within the refurbishment policy? The energy certification is presented as the main stimulus to boost energy rehabilitation on the stock. As we said at the beginning of the presentation, the energy certification informs the future user of the building of its energy characteristics and the annual economic cost in energy. Also includes a list of recommendations which, combined with an economic budget to improve the energy rating, encourage actions to make energy refurbishment. And finally, creates a framework to support financing for individuals and companies to audit and refurbish their homes and workplace. So the main goal of the energy certification would be the energy renovation of buildings. Okay, well, here we just can see, I'm going to see it fast. There are many possibilities to stimulate the building renovation. We can have some penalties, some preferential loans, some grants, some tax incentives. We can help with the audit. So there are many possibilities to stimulate the building renovation. We have selected a couple of programs. The first one is a German program called KfW, Loans and Subsidies from Reconstruction Credit Institute. And it gives loans and grants if you want to refurbish your building, your home, depending on how much is going to consume the building. Okay. Finally, there is another example here, the Programa Parer in Spain. The main goals would be contribute to achieve the objectives set out in the Directive 2012-27, improve overall building energy rating of at least 1 letter on the scale of emissions. And the types of action would be improvement of the energy efficiency in the thermal envelope, in heating and cooling, and with renewable energies. So we can find a lot of programs, especially in Europe, for get to the home improvements. Well, this is the end. Thank you very much all for your attention. And if you have any questions, let's start with that now.